couldn't do this in chapter 4. Okay, we couldn't do this in chapter 4 because we couldn't factor. So hopefully you didn't forget the skill set of factoring, because we really need that. Okay, we're really trying to use those algebraic skills from the previous lesson, or so from the previous unit, to allow us to do everything we want to do with quadratics. Okay, so one of the things that we really want to learn how to do is solve quadratic equations, because there's a bunch of word problems waiting for us. Okay, so just do a quick refresher. Let's solve a quadratic equation. So this is, in a linear equation. This is what you did in grade 9. So 3x plus 4 equals 9. What you did was subtract both sides by 4. You get 5 on the right side, divide both sides by 3. And you get x equals 5 over 3. Okay. So then I get some students and they try to solve a quadratic equation. They rearrange to get x squared minus 5x equals 6. And then they try to factor x, something like this. Unfortunately, then there's really nowhere you can progress. Okay, yeah, so there is something you can actually do with x squared minus 5x, but we will explore that in the next lesson, because in this lesson we were focusing on factoring. Okay, we can solve this equation by combining two different skills, or two different mathematical ideas. Okay, so you need to be able to factor, and once you can factor, you can talk about the zero product property. The zero product property states that if a times b is 0, either a is 0 or b is 0, or both a and b are 0. Okay, so let's talk about this one. Let's look at this equation. So find the root. Which is basically asking for the solutions to the equation. X squared minus 5x minus 24. Okay, I can't tell you when the left side is equal to 0 right now. Okay, because it's a term minus another term minus another term. I can't answer that question. But if I express this as a product, okay, x minus, simple trinomial, what multiplies a negative 24, what adds to negative 5. So think of the factors of 24. You got 1 and 24, 2 and 12, 8 and 3, and of course 6 and 4, but 8 and 3 is good. So negative 8 plus 3, because negative 8 and 3 multiplies a negative 24 and adds to negative 5. So hopefully you didn't forget your factoring, because it's critical for this lesson. Okay, so look, you can now apply the zero product property. When is the left side equal to 0? I can answer the question now. I couldn't answer it previously in the first line, but now I can tell you exactly when the left side is equal to 0. The left side is equal to 0 when either of these factors are 0, based on the zero product property. So just in case you don't know, I can set each factor equals 0. So set x minus 8 and x plus 3 equals 0. Okay, so when is x minus 8 equals 0? I'm pretty sure you knew this already, but when x is equal to 8. And when is x plus 3 equals 0? When x is negative 3. And you know what? If you don't feel really confident or comfortable with this, then you can sub it back in and make sure that it really makes the left side equal 0. And I assure you, 8 and negative 3 are both solutions to this equation. Okay, so now what about this equation? X squared plus 3x equals 28. Now, the first thing you should do is set it equal to 0. Okay, set the right side or the left side equal to 0. So in this case, I'm going to subtract both sides by 28. Why should you set equal to 0? Because you're trying to apply the zero product property, not the 28 product property. Okay, so you really want the zero product property, because 28 is really, there are infinite ways to get to 28, and that tells you nothing about the factors. So now let's factor. Okay, so let's see what I spoiled it. Sorry. Well, multiplies a negative 28 and adds to 3. So 7 and negative 4. So you can write down the factors equal to 0. But you know what? I'm going to jump straight to the solution. I think we can do that. So from the factor x plus 7, I get the solution negative 7. From the factor x minus 4, I get the solution 4. Okay, because -7 makes the first factor 0, and 4 makes the second factor 0. So these are the solutions based on the zero product property. And of course, you can sub it back in and check with your equation. All right, next one, 6x squared plus 13x equals 5. So set it equal to 0, so you can apply the zero product property. Ooh, factor. Can you factor a complex trinomial? Let's see, 2, 3. Let's see, if I put a 5 here, that'll give me the 15. Yep, that's good. 15 and 2, so plus 15 minus 2. Bam. Okay, so set each factor equal to 0. You're basically applying the zero product property, so the solutions to this equation is either -5/2 or 1/3. All right, next one. Divide everything by 2, so you get x squared minus 4x minus 5. Right, it's an equation, just like last year in grade 9. You can divide both sides by 2, absolutely. And here, it's a quadratic equation, divide both sides by 2. Factor, simple trinomial, what multiplies a -5 and add to -4? -5 and 1. So based on the factors, apply the zero product property. So the roots to this equation are 5 and -1. Beautiful. So what we just did, we solved a bunch of quadratic equations by factoring. Let's take a look at the next page. So now that we can solve a quadratic equation by factoring, let's apply that skill and answer these word problems. So if a ball is tossed from a building, its height is given by h equals -5t squared plus 15t plus 90. H is the height of the ball above ground in meters, and t is in seconds after being tossed. So when does the ball hit the ground? You know what? Let h equal 0. We're just trying to find out when the ball is at the ground. So let's see. Plus 15t plus 90. The first thing I'm going to do is divide both sides by -5. And then I try to factor. So what multiplies -18 and adds to -3? Simple trinomial. So -6 and +3. Let's apply the zero product property. So t equals 6 or t equals -3. Wait a minute, -3? How does the ball hit the ground after -3 seconds? So we're going to reject this because t has to be greater than or equal to 0. Okay? You can't hit the ground before I threw the ball. Okay, so greater than or equal to 0. Therefore, there's only one acceptable solution here. Okay, so instead of saying reject, you can also use the word inadmissible, which is another fancy way of saying it's not a great solution. We have to reject it, but you should really provide the reason why you did that. So yeah, t equals 6 is a great answer. Therefore, the ball hits the ground after 6 seconds. Alright, let's try next one. Very similar, but instead of finding out when the ball hits the ground, when is the ball 10 meters above the ground? Okay, so instead of letting h equal 0, we are going to say let h equal 10. But the strategy is the same. Oops. You have a quadratic equation, and we are going to solve it. So let's set this equal to 0. I'm going to bring the terms to the left side. So this will be 4t squared minus 12t plus 10 minus 26 equals 0. So we have 4t squared minus 12t minus 16 equals 0. Divide both sides by 4. Simple trinomial. What multiplies a -4 and adds to -3? So multiplies -4, adds -3 is -4 and 1. So t equals 4 or t equals -1. Like I said, wait a second, -1, that makes no sense. Therefore, reject, because t is greater than or equal to 0. Okay, you can't be 10 meters above ground before I threw it. So you can actually be at 0 because the ball might be 10 meters above ground to begin with, but definitely not when it's negative. Okay, so therefore the ball is 10 meters above the ground after 4 seconds. And you know what? If you're in doubt, what you can do is sub in 4. Oops. So negative. There we go. Oops. I made a boo-boo. Oh, I won't be fancy. After 4 seconds, right? Yep, 4 seconds. Let's check. There we go. After 4 seconds, it's 10 meters high. Alright, find the roots to the quadratic equation. Seems easy enough. Let's do it. X squared minus 4x plus 1 equals 0. What multiplies the 1 and adds -4? Wait a minute. I can't factor this. So we did some examples like this in the previous unit, but I just want to highlight what I said in the solutions of the homework. Okay, so you can actually factor this, okay, but you won't know how to, because if I'll show you what the factors are, they're actually really not friendly. So it's x minus 2 plus root 3 and x minus 2 minus root 3, okay? So what we say here, okay, and we said this in the last unit, it's not factorable over the rational numbers. What that means is that if you take a look at the factors, look at the constant term, it's an irrational number, okay? It's not a rational number. So you can actually factor this over the irrational numbers. But if you're thinking about rational numbers, then you won't be able to factor it, okay? So this is factorable over the irrational numbers, but unfortunately with the factoring strategies that we're using when we're factoring simple or complex trinomials, we're only thinking about the factoring over the rational numbers. So basically, in short, if it's not factorable over the rational numbers, we just say it's not factorable. Okay, if a student says to me, this expression is not factorable, I understand what they're saying. What they're really saying is it's not factorable over the rational numbers. Okay, so just be careful, okay? Because it is factorable. It's just not factorable over the rational numbers. You get these ugly factors, which, yeah, you just can't get them by using the skill set that we had from the previous chapter. Okay, so this leads to another question. We are great at solving quadratic equations when we can factor, but what about this guy? How can we solve this quadratic equation? I assure you, there are two beautiful answers for this quadratic equation. But if it's not factorable, then what do we do? So that's a perfect segue for the next lesson.